Hi everyone, welcome back to my channel lecture series on microcontroller and ARM processor. In this video, I am going to explain how to write an assembly language program for direction and angle control of stepper motor using 8051 microcontroller. Before moving into the programming part, you have to understand what is a stepper motor and how it works. Stepper motor is also called as a step motor, which is used for converting a digital pulse into a mechanical shaft rotation. If you give one pulse to the stepper motor will take one step. If you buy a motor with a step angle of 1.8 degree, if you give a pulse to it, it will take 1.8 degree. So after knowing the step angle, you can stop the stepper motor with the required angle. So how to stop the motor at the required angle is, if you want to stop the motor at 90 degree, you need to find out the number of steps. So for 90 degree, 90 by 1.8, it will give 50 steps. Similarly for 180 by 1.8, it will give 100 steps, 270, 150 steps, and 360, 200 steps. For each and every cases, we need to find out the hexa equivalent for this. For 50 step, the hexa equivalent is 32H. Similarly for 100, 150, 200, we have a hexa data of 64H, 96H and C8H. If we give this data into the program, the motor will stop at the particular angle. So before moving on to moving on to how to find the sequence for rotating the motor into clockwise and anti-clockwise direction continuously, you need to know how to energize the motor. There are three different modes of operations we know. We have one is off stepping mode, full stepping mode and micro stepping. In this video I am going to explain only the full step mode of operation. In full step mode of operation we have two modes. One is one phase on mode and another one is two phase on mode. In one phase on mode only one phase will be energized at a time, and two phase on mode the two phases are energized at a time. So if you take a comparison of one phase on mode and two phase on mode, is the two phase on mode provides improved torque and speed performance. Especially if you take the torque, it will give the highest torque of the 30 to 40% of the higher improved torque compared with the single phase on mode. And also we have a off step mode of operation. In off step mode, the number of steps taken by the motor to complete one revolution gets doubled, so that the step angle reduces into half, which provides a smoother operation and twice the resolution. So in this video I mentioned I'm going to talk about only the full step mode of operation in detail. So in full step mode of operation, I need to energize two windings at a time. So for that, what I have done is I have taken a hexa data from 0 to F and I have converted this hexa data into a binary values. In binary values, I have to find out the data which has two ones. So I have identified the data 3, 5, 6, 9, A, C. So these data has two ones. The two ones in the sense you are going to energize a pair of winding at a time. So if you have a 4 winding stepper motor, out of these 6 data you can select only 4 data. So that 4 data is generally used for rotating the motor into clockwise, and if you reverse the sequence it will be rotating into anti-clockwise direction. So how to find out the order of the sequence? So here if you see the table, I have used 4 winding motors. A and A dash are internally paired, then B, B dash are internally paired. So I have written A, B, A dash, B dash, and this I am going to rotate the rotor into clockwise direction. So with respect to A phase, I am going to energize my stator coil, and I need to rotate the rotor into clockwise direction. So with respect to A phase, I am energizing, so I am making the contact close to the A phase, and the adjacent phase is B dash, so I am going to make this contact also closed. So the next step, I am keeping this B dash is as it is, and I am opening the A switch, making the B switch to close. The next step, I am keeping the B switch closed and making the B dash is open and making the A dash is closed. Then again next is fourth step, I am going to make A dash is as it is, and I am going to open the B switch and A switch I am going to close. So in this way, if you make the contact closing and opening, you can able to rotate the motor into clockwise direction. If you take the hexa equivalent for this first case is 9, this is 5, 6, A. So if you provide this sequence in this order 9, 5, 6, A, you can rotate the motor into clockwise direction. If you reverse this order like A, 6, 5, 9, you can rotate this motor into a counterclockwise direction. Okay, if you have a 6 winding stepper motor, you can use all the 6 data. Since I am going to use only 4 winding stepper motor, so out of this 6 data, I have used 4 data. So you can just find out from this. This is a 9 I am using, 6 I am using, 5 I am using, 8. These are the 4 data I am going to use to rotate the motor into clockwise direction. So if you find out, if you see the direction of sequence, the 956A is used for clockwise direction and A659 is used for counterclockwise direction. Now we'll be moving on to the programming part. How to write a assembly language program using 8051 microcontroller. Here I am using R4. R4 I have initialized for number of steps. If you want to stop the motor at 90 degree, you can provide the hexa equivalent data here so that it will be moved to the R4 register. And I'm going to load 4 data to rotate the motor into clockwise direction continuously. So I'm going to load this data into a lookup table address. The lookup table is generally used to load the set of data. So I'm using 4600 as an address for the lookup table, and I'm going to load all the 4 data here. When you increment your DPTR by 1, then it will be incrementing the address by 1, 4601, and fetch the second data. Likewise, you can increment your DPTR to fetch all the 4 data. Then I'm going to use 4 as a count, how many data I'm going to load it in the lookup table. So I'm going to make it as count here, and I'm going to copy the data available in the DPTR. Okay, 4600 is the data available is in 09. I'm going to move to the accumulator. So this is a 4600. I'm having the data 09 moving to the accumulator. Now using a push instruction, I can just push the higher order byte from the stack to the stack memory pointed by the stack pointer. So here it is a 8-bit data. You can take the higher order byte, then I can take the lower order byte. So you are just pushing this data to the stack memory pointed by the stack pointer. After getting this data, you can send this data to the output port of your microcontroller. So here the port address I am using is this is for port A port. Address is FFC0. So after getting this 09 data, you can move this, you can load the FFC0 address to the DPTR. Then the data available in accumulator, you are moving to the address of DPTR. So here the address of DPTR is nothing but FFC0, that is the output port address of your microcontroller. So I'm just sending the 09 data to the address of port A address. So after sending this data, you can decrement your jump if not equal to 0, that is R4 is not equal to 0. You can call this delay subroutine. In delay subroutine, I used 2 loops. With the 2 registers, the R1 is the inner loop and R2 is the outer loop. In the inner loop, I am defining the highest hexa data. So if you decrement this R1 register, it will be decrementing the value which is loaded through the R1. So here the FF is loaded to R1 and I am decrementing FF to 00. Okay, each step I am decrementing this FF into then FE, FC, like that it will keep on decrement and it will until it reaches to 00. This is the first step. The next, once it is 0, then it will call the second delay program, that is decrement jump if not equal to 0. It will call, the R2 is not equal to 0, then you can call delay 2. Delay 2 in the sense, again you are loading the data FF to R1 and you keep on decrementing this FF into 00. So how many times it will do? It will do totally 3 times. Okay, FF to 00, it will take 3 times. It will keep on execute the value. Once this is completed, it will be jump to this pop instruction. The pop means you are going to retrieve the content at the stack pointer into DPL. So here the pop is retrieves the last value which is pushed from the stack. So here the last value pushed from the stack is a lower order byte and you are going to pop the lower order byte first, then the higher order byte. So the pop instruction is generally used to retrieve the data pushed from the stack pointer. So 09 is the data you are pushed to the stack pointer. After which you are going to increment your DPTR. So 09 data you have fetched and you are going to fetch the second data 05. For that I am incrementing my DPTR. The DPTR address is 4600. So decrement jump if not equal to 0, that is R0 is not equal to 0. There are 4 data have not fetched it. Then you have to again load the data to the accumulator. Then you can send the second data for energizing the stepper motor to take the next step. Until it completes the 4 data, it will keep on jump to the J0 and load the second data. Again you are moving the second data to the port address and you are calling the delay. Then you are taking the third data. Likewise it goes, it will take all the 4 data. So for each and every data, before it fetches the next data, you have to call a delay, because as you all know that they are going to opening and closing the switches. So 09 data is given, you are going to make 2 windings to energize, a pair of windings to energize. You have to open the contact, then again you have to close this next set of contact. So for making the next set of contact closed, you have to have a delay between them. Okay, so for every cases after 09 is fetched, you are going to have some delay, then 05 is fetched, after that we have a delay, then 06 is fetched, then we have a delay, so the 0A will be fetched at the last. So for each and every stages we have to have a delay, then only the motor will rotate into continuous manner. If you increase the delay or decrease the delay, based on that you can control the speed of the motor rotation. Okay, so then you are going to use S jump start. You are going to load the next again the 4 set of data into the lookup table address, and you can fetch all the 4 data, send it to the output port so that the motor will be rotating in a continuous manner. So if you want to stop at a required angle, you have to use a number of steps. So here the R4 I have used, and here the decrement jump if not equal to 0, it will call the delay program. If it is reaches 0, then the motor will be stopped with the number of steps whatever you have given in the first instruction itself. Okay, if 90 degree if you give, only it will take 90 degree and it will get stopped until it will call the set of data which is loaded in the lookup table, and it will keep on running. Okay, thank you for watching.